In this video, we're going to look at Euclid's proposition number 1, constructing an equilateral triangle. And we're going to look at the traditional approach, and we're also going to look at a rather novel way of getting at it that I discuss in my Sign of the Times blog post, Euclid Walks the Plank. Here we have our web sketchpad model, and it comes with two tools, a compass tool and a tool that allows us to construct a generic triangle. How can we construct an equilateral triangle? Well, I'll start with my compass tool. I'll tap the icon, and I see a preview for what I'm about to construct. A circle with a center point and a point on the circumference. The center point is glowing, which indicates that I need to place it somewhere. So I'll tap, and my center is placed. Now the point on the circumference is glowing, so I'll tap to place that. And my circle is complete. Now, the traditional construction for the equilateral triangle has us constructing a second circle, and that second circle will have the same radius as the first and is interlocked with the first. This center point of my new circle will merge right there with the point on my first circle on the circumference, and the point that's glowing now on the circumference of my second circle, I will merge with the center of my original circle. So here we have our two circles, and when I drag either point, they grow and shrink in unison. Here are two of the vertices of my equilateral triangle, and here is the third. And we can prove it's an equilateral triangle by noticing that all three sides, when we construct them, are radii of these two circles, which themselves are the same size. So let's actually construct that equilateral triangle. I'll tap my triangle tool, and one by one, I will place the three vertices of that triangle. The first vertex I'll place here, the second I'll place here, and the third I'll place at the intersection of the two circles. So there is my equilateral triangle. So far this is completely traditional. This is how Euclid did it, and this is how you'll find it presented in dynamic geometry curricula. Now, as I mentioned in my post, there are several ways that this is presented. Students are either given step-by-step instructions for how to do this and asked why the construction method works, or they might be asked to figure it out for themselves, although I think that's less common. Another approach that I suggest in my blog post is perhaps to start with students constructing an isosceles triangle, so that they get to understand the role of the circle that plays. So we might start with a circle and then merge the other two vertices of this triangle to the circumference and the third vertex to the center. And so now we see that this triangle grows and shrinks and changes its size and shape, but because two of its sides are radii of the circle, we have an isosceles triangle. So that's another approach at getting at the equilateral triangle construction, but I'd also like to show you one other method that I've come up with that I think is a bit more unusual. So here we have a square piece of land, and over here in the opposite corner we have another square piece of land, and we have water in the rest of the sketch. And our goal is to connect this piece of land to this piece of land with planks, so essentially to build a boardwalk of planks. And we have our first plank already here in place, connecting A to B. And my one requirement for building this boardwalk is that all the planks be the same length. So this plank tool, there are two of them, one that constructs beige planks and the other that constructs green, allow me to construct a plank. So just to show you how that works, if I tap on this tool, I see a preview of my plank. I can attach one end to B and the other end anywhere I like. And that works, but the problem is that it doesn't meet my requirement that I want the two planks to be of the same length. So let's undo that. So how can I construct the second plank to be of the same length as the first? Well, I'm going to use my compass tool. I'll make B the center of my circle, and the circle will pass through point A, my starting point. And now I can construct my plank so that it begins at B, and I will attach it to the circumference of my circle. And this guarantees that wherever this endpoint is along the circle's circumference, the length of my two planks are the same. So I can continue this method, this time using the endpoint of my second plank as the center of my circle. And here's the new circle, which has the same radius as the first. And let's construct our third plank in our boardwalk. And let's see, can I do it with one more plank? Well, let's try. So there's the center, and my circle passes through here. And oh yeah, it looks like since the circle intersects the square, and inside the square here, I can construct my fourth boardwalk plank, and there I can go from A all the way to the end. I can drag these points, and if I do, I have to adjust my boardwalk a little sometimes so that it continues to pass through this land here on the square. And if I make this first plank shorter, thus making all the planks shorter, I have to add more planks to my boardwalk, which can be fun and good practice for students to get used to using the compass tool. But let's go back to this position here. Now what I'd like to do is to construct another boardwalk of planks, this time using the green planks. And I don't want to walk along any of these existing planks that are here, but it's okay if I pass through any of these intersections of where two planks meet, like at point B or right here. And my only requirement now is that I only can use and construct two additional circles. I can use everything that's here, but I can add two more circles to what I have. So this is an interesting challenge, and you might just want to stop here and think about it before I go on, because what I'm going to do now is to construct another circle here with center at A, passing through B. And let's see, I'll construct my green planks to start here, and I'm going to look at the intersection of this circle with center at B and this circle with center at A. And that's right here. So that's going to be the first leg of my new boardwalk, which I may not have mentioned it, but again, the requirement is the same, that all the green planks be of the same length. So here's my first plank. My second will go from here to here, because it's okay if I pass through this point. For my next plank, I am going to see now the circle centered at B and the circle centered here, and those intersect right here. So I'm going to use that as the end point for my next plank. And let's now go from here to here. And now I'm going to look at the two circles that intersect, one with center right here, the other with center right there. So here's my next plank. And let's now connect that here. And I'm allowed to add one more circle. So let's connect, let's make this the center and use that point there to construct the radius. And I'm going to look where the circle centered here and the circle centered there intersect. And that's right over here. And one more plank. And there we're done. So it turns out our new boardwalk has planks of the same length as our beige boardwalk. We have this path that goes like this, passes through the intersection points of our original boardwalk. All the planks are of the same length, and we only needed to add 2 new circles, one centered at A and one centered at the end point of our boardwalk. And notice something really kind of cool here. In addition to making this new boardwalk path, if you look at the combination of the beige path with the green path, well, what do we have? We have equilateral triangles. We have 4 of them, in fact, each composed of 2 green boardwalk planks and 1 beige plank. And I can drag these a little bit and experiment and see that these always remain equilateral. So as I mentioned in my blog post, this wasn't how I intended the lesson to go, but the fact that these planks come together to make equilateral triangles is a really neat introduction to Euclid's proposition number 1.